Hello and welcome. The green area is a rectangle whose one vertex touches the red circle, which is inscribed in a square. The deficit area of the red circle is of a quarter circle whose radius is half the side of the square. Find the area of the red region. This is a typical example where very less information is provided. We will break this question into two parts. In step 1, we will find the radius, and in step 2, we will find the area of the red region. To find the radius, we will first assume the remaining part of the circle. We will solve this problem using two methods. First will be using geometry and second will be using coordinate geometry. From the vertex of the rectangle, draw the radius of the circle. Draw vertical and horizontal lines from the center of circle. From the vertex of the rectangle, draw perpendiculars parallel to the sides of the square. The vertical blue line is 10 less than the radius. The vertical yellow line, that is the radius, consists of the vertical blue dotted line and the breadth of the green rectangle. So the blue dotted line is r minus 10. Similarly, the horizontal blue line is 20 less than the radius. As we see, the blue dotted lines and the vertical and horizontal radii are perpendiculars. Thus, this forms a rectangle. Therefore, opposite sides are equal here. The blue dotted line, that is r minus 10, and the blue dotted line, that is r minus 20, are the legs of the right triangle, where the hypotenuse is r. Therefore, r minus 10 whole squared plus r minus 20 whole squared is r squared. If we simplify it, we get r squared minus 60 times r plus 500 is 0. On factoring it, we get r minus 50 times r minus 10 is 0. Here, either r should be 50 or r should be 10. The length of the horizontal blue dotted line is r minus 20. If we consider r as 10, this makes the length of the blue dotted horizontal line as negative 10, which is not possible. So we consider that the radius is 50 units. Now we will solve this problem using second approach, that is using coordinate geometry. First we will rotate the circle counterclockwise 90 degree. Draw a Cartesian plane through the vertex of square at the origin. The length and breadth of the green rectangle here are 10 and 20. So the coordinates 10 and 20 are already present on the circle. Coordinates of the center of circle is r, r. Equation of a circle is x minus h whole squared plus y minus k whole squared is r squared. H and k are center, which is r, r. 10 and 20 lie on the circle. Thus, we will substitute the values of x and y with 10 and 20, and we will arrive at the equation as 10 minus r whole squared plus 20 minus r whole squared equals to r squared. Simplifying it, we get r squared minus 60r plus 500 is 0. And similar to our previous calculations, we arrive at radius is 50 units. This method is very much similar to our previous method where we used Pythagorean theorem. We are done with the step 1, that is finding the radius. We found that radius is 50 units. Now in step 2, we will find the area of the red region. To find the area of the red region, we will first assume the remaining part of the circle. To find the area, start by dissecting the circle. Draw radii at the end of the quarter circle to be dissected. Make the chord joining the radii. Draw another pair of lines parallel to the radii. Area of the red region is simplified as the red region is area of the circle minus the smaller segment minus the smaller segment again. In this case, both the segments are similar. In the yellow dotted square, we can see that there are two quarter circles, one with the center at bottom left corner and one with the center at top right corner. Both have same radii. Thus, we can conclude that the circular segments forming here will be equal. Therefore, we can say this is equivalent to the area of the full circle minus 2 times the area of the circular segment. The area of the circular segment is quarter area of the circle minus the right triangle forming at the center. Here, the area of the quarter circle can be found as 1/4 area of circle, which is 1/4 into pi r squared, where r is 50 units. Thus, the area of the quarter circle is 625 pi. The area of the right triangle here is half into base into height. The base and height both are radii. The area of the right triangle here is half into radius squared. If we impute the value of radius as 50, we get the area of the right triangle as 1250 units. The area of the circular segment here is 625 pi minus 1250, which can be simply written as 625 times pi minus 2. Now the area of the red region is simplified as the area of the full circle minus 2 times the area of the circular segment. The area of the circular segment is 625 pi minus 2. We impute the values here and we see the area of the red region is pi r squared minus 1250 times pi minus 2. Simplifying it, we get the area of the red region as 1250 times pi plus 2. We find the area as 1250 times pi plus 2 units. If you have any doubts, you can write about it in the comment section. And if you want me to solve any problem, you can write to me at mathematize0@gmail.com. Thank you.